All right, so we're going to be dealing with simplifying, adding, and subtracting radical expressions. So let's begin with something simple as example A. Notice that my radicals are the same thing. Right, I have square root of 2, square root of 2. So all I'm going to do, I'm going to add the numbers on the outside. So I'm going to call this 7 square root of 2. Don't change the radical, or the radicand in this case, the number in the inside. Don't change the number in the inside. It's just for you to know what to combine. I just added the numbers on the outside, 4 plus 3. That's how I got the 7. Example number B. I notice my radicals are exactly the same thing. So I'm just going to deal with the number on the outside, 2 minus 5. So let me call this negative 3 radical 3. Now looking at example C, I notice that they're not the exact same thing. The radicals are a little bit different, so I must combine them, or I must simplify them. So for the square root of 24, let me think of perfect squares. I know 2 squared is 4. I know 3 squared is 9. I know 4 squared is 16. I know 5 squared is 25. And 6 squared equals 36. And I can continue with my list. Now, square root of 24, let me break that. So there's a 3 in the front. Square root of 24, let me break that into 2 radicals such that one of them is a perfect square. So I'm thinking 2 numbers that multiplied equals 24. One of my numbers must be from this list at the right. So I'm going to think of 4 times 6. One of my square roots is a perfect square root. Then I'm going to go plus. Now, square root of 54, let me break that as 9 times 6. Notice how, once again, one of my numbers, I'm picking it from my list at the right. 2 numbers that multiply equals 54, one of them from that list. I know the square root of 4 is 2. Since 2 squared is 4, so the square root of 4 is 2. Multiply these 2 numbers on the outside, so I have 6 radical 6. Plus, I know square root of 9 is 3, so I have 3 radical 6. Now to simplify this, I'm just going to call this 9 radical 6. Notice that when I simplified them, they had the same square root, the same radical. That's why I was able to combine them. Now, let's take a look at another example. Once again, let me remember my perfect squares. 2 squared is 4. 3 squared is 9. 4 squared is 16. And I know I can continue. Now, this one, I'm going to break this. My 2 on the outside. Square root of 20. Remember, I'm going to think of 2 numbers that multiplied equals 20. One of my numbers has to be from the list on the right. I'm going to think of 4 times 5. And then my square root of x. Minus. Now, square root of 45. I'm going to leave my x alone. Square root of 45. Once again, I'm thinking 2 numbers that multiplied equals 45. One of my numbers from the list. So I'm going to go as 9 times 5. All right, so I know the square root of 4 is 2. When I combine these, I have to multiply them. I have 4 square root of 5x. I know square root of 9 is 3. So this gives me minus 3 square root of 5x. Notice that these 2 that I had in radicals, I just multiplied them. Now I notice that my radicals are the same thing, 5x. So I just look at the numbers on the outside. 4 minus 3, that's going to give me 1 square root of 5x. Notice how my 1 at the front is optional, so I chose not to write it. Now in example E, my radicals are different. Square root of 3, square root of 5. I cannot simplify them anymore. They're not the same radical. I cannot simplify them and make them the same radical. So that is as simple as we can go. It's just 2 square root of 3 minus 4 square root of 5. I cannot simplify this anymore. Now, you try at home. These are some examples for you guys to try it. The answers for these, showing them to you. So this is for you guys to try it, and that's what you guys should get. So more of the examples. These are examples, once again, for you guys to try at home. Now, your answers for these should be that. Now, let's take a look at this one. Do notice that now I'm going to be dealing with the cube roots. So I must know the perfect cubes. I know 2 to the third is 8. I know 3 to the third is 27. 4 to the third, 64. 5 to the third, 125. And I can continue my list. My numbers are not that big, so I'm not going to make a big list. So looking at the first radical, my 2 on the front, my radical, I'm going to break it into 2 radicals. Notice I did cube roots on both of them. I'm thinking 2 numbers that multiplied equals 16. One of them is from my list on the right. So I'm going to go 8 times 2. And I'm going to go minus 5. My radical 54, I'm going to break it into 2 radicals as well. Thinking 2 numbers that multiplied equals 54. One of my numbers is from the right. So I'm going to go 27 times 2. I know the cube root of 8 is 2, right? 2 to the third is 8. So the cube root of 8 is 2. So here I have 4 cube root of 2 minus, I know the cube root of 27 is 3, right? 3 to the third is 27. So the cube root of 27 is 3. So this gives me minus 15th cube root of 2. Now I notice my roots are the same, cube root of 2. So I'm just going to look at the numbers on the outside. 4 minus 15 is going to give me negative 11 cube root of 2. Looking at example B. I have my 2 in the front. I have no numbers. Then I have cube root of x squared y. Plus, I have the cube root of 8. And then cube root of x to the 5th, y to the 4th. I just want to separate numbers and letters. On my first one, I didn't have a number in the inside. Now, I cannot simplify my first radical because I cannot simplify it anymore because my exponents are smaller than the root. Remember, I go exponent divided by the root. So in this case, I just get 2 cube root of x squared y. That's all I can do. It's my plus sign. Now, here, the cube root of 8, that's a perfect cube. Cube root of 8 is 2. Now, when it comes to letters, since my exponents are bigger than the roots, I remembered a few sections before, I used to tell you guys is exponent divided by root. So I'm thinking 5 divided by 3. I know 3 goes into 5 one time, so I get x to the 1 on the outside. And then I have a remainder of 2. Notice I put it back in the radical. Now for the y, 4 divided by 3. I know 3 goes into 4 one time, so y to the 1 comes out. And I have a remainder of 1. So y to the 1 goes inside. Now I notice that they have the same radical. So I'm going to simplify this as, let me put in inside parentheses 2 plus 2xy. Notice I just added the numbers on the outside, but I cannot combine them since they're not like terms. So I'm just going to put it inside parentheses, and then afterwards the cube root of x squared y. Now this is for you guys to try at home. And those are the answers. Now, what if I add fractions? What if I'm going to add some fractions? So I can either have a radical of a fraction, or I can have a fraction of two radicals. What I'm going to do is I'm going to break it into a fraction of two radicals. And if I have a number in the front, I'm going to bring it to the top. What I mean with this is I'm going to break this as 2 square root of 75 over square root of 16. Notice how my radical, I split it as a fraction of two radicals. My 2 at the front, I brought it to the top, plus 4 radical 8 over radical 32. Okay, so I got to work something out. First of all, I got to remember my perfect squares, right? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, on and on and on. So looking at my first fraction, looking at the top, my 2, I'm going to leave it as a 2. Square root of 75, I'm going to break that as 2 square roots. One of my numbers has to be from the list, right? 2 numbers that multiplied equals 75. So I'm thinking 25 times 3. At the bottom, square root of 16, that's a perfect square. I'm just going to leave it as square root of 16. Plus, my second fraction, there's a 4. My square root of 8, I'm going to break that as 4 times 2. Once again, my first number, my 4, I chose it from the list on the right. Now, square root of 32, I can go that as 16 times 2. All right, so here I know square root of 25 is 5. Square root of 16 is 4. Square root of 4 is 2. Square root of 16 is 4. So looking at my first fraction, I have 10 radical 3 over 4. Looking at my second fraction, my radical 2's cancel out. I have the same factor on the top and the bottom. So that gives me 8 over 4. Now what I'm going to do is I'm going to combine them. I'm dealing with addition. The good thing is they have the same denominator. So I'm just going to have 10 radical 3 plus 8 over 4. Now, if my numbers that I'm highlighting, all of these numbers can be divided by something to make them smaller, then do so. In this case, let me divide everything by 2. Notice how my radicals, I'm not doing it, and I said I'm going to divide all of them by the same number. So I'm going to get 5 radical 3 plus 4 over 2. Okay, now let's take a look at example B. I must know my perfect cubes. For us to not get confused, let me change it to a different color. I must know my perfect cubes. I know 2 to the third is 8. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. I don't have big numbers, so I'm just going to not have a big list. I'm just going to stop that. So I'm just going to go as 10 cube root of 5 over cube root of x to the 6 minus 3 cube root of 4 over cube root of x to the 9th. Now, my numbers on the top, my radicals, there's not much I can do. So I'm just going to call that as 10 cube root of 5 over x to the 2. Now, that one I could simplify. Remember, exponent divided by root minus 3 cube root of 4 over x to the 3. In order for me to simplify, in order for me to combine them in a fraction, they must have the same denominator. So let me multiply it on the first fraction, top and bottom by x. So now I have a 10x, and here I have x to the 3rd. I multiplied top and bottom by x just so I could have the same denominator, x to the 3rd. Now on the top, I'm going to have 10x, the cube root of 5, minus 3, the cube root of 4. I multiply the first fraction by x, top and bottom, just so I could have the same denominator. Once I have the same denominator, I just copy the denominator and look at the top. I cannot combine them anymore because they have different roots, different radicals. All right, so this is for you guys to try at home. The answers, there you go. Those are the answers. Okay, so that's this section.